Hello! Here you're going to look at the graphs for the motion of a ball projected vertically upwards. Let's select displacement from the menu above the graph. And let's click play and watch the ball rise and fall. Look at the displacement time graph. At what time does it reach its highest point? Yes, at 3 seconds. Let's select velocity from the graph menu. What is the velocity of the ball when it reaches its highest point at the 3 seconds? It's 0 meters per second. What is true about the velocity values after 3 seconds? Yes, they are all negative. When there is a movement in two directions, it's necessary to distinguish between up and down. This is done by marking anything upwards positive and anything downwards negative, meaning by that the velocity, this is true of the directions of all the vector quantities: displacement, velocity, force, and acceleration. Let's select acceleration from the graph menu. Look at the acceleration time graph and explain its shape. Yes, it's a straight horizontal line because acceleration is constant. Let's select displacement from the graph menu again. Look at the displacement time graph and explain its shape. Yes, the displacement increases more and more slowly as the ball slows down, then more and more quickly as it speeds up. Let's select formula and look at the equation for each graph. So the acceleration was a straight line since it's constant and it's equal to the negative of the gravitational constant, which is equal to minus 9.81 meters per second squared. The velocity is equal to the initial velocity on the y-axis minus gt, where g is the gravitational constant and t is the time. Replacing minus g by the acceleration and substituting the initial velocity by its value, which is equal to 30 meters per second, the velocity equation gives a straight line. The intercept is 30 meters per second, which is the initial velocity, and the slope is a decreasing slope, which is equal to the acceleration minus 9.81. The displacement shows a parabola which has a t-squared dependent behavior with an offset equal to u multiplied by time, where u is the initial velocity equal to 30. That's all.